Hi, I'm Balaji Chipada and welcome back to my YouTube channel. In today's video, we are going to learn an important concept called null value treatment in data frames. In real world, you might get huge amounts of data and in 90% of the cases, the data is not going to be in the format that you want. There might be some data type discrepancies or mismatches and there might be a lot of null values. Let's say you have a data frame of shape 1 million records cross 500 columns, and in majority of the cases you will not have the data in the whole data set. There might be so many null values. So at that time, how do you deal with this data set and what you have to do in that scenario? So those are all the things that we would learn in today's video. So without any delay, let's get started. As usual, let's start with importing pandas as PD, and I have a data set that I uploaded here. Let me give you a little brief of the data set. It's an employee data set. I will also link this data set in the description below. Please do check it out and to download for the same. And it has multiple columns. In total, it has 8 columns. It's an employee data. We have employee ID, employee name, age, weight, and how many years that they have worked for this company, salary, city, and designation. And inside this dataset, there are some columns in which it contains null values. That means there is no information on the same. Null basically means not available as well. You can call it as null, you can call it as none, and np.nan. All of these are treated as null values inside your pandas data frame. Now let's load the dataset df equal to p.readcsv, and if I see, I have 1000 records and 8 columns, and if I do a df.head, I get to see the top 5 records. Hopefully that is clear. And then now this is the important function. If I do df.info, I get to see the high level stats along with the null values of my data frame. And if you notice here, I have total 1000 records, and out of which I have these many columns, and each column how many null values it does contain. It is saying 1000 non-null values. That means all values are present. Okay, if you notice this age column, it says 950 non-null values. That means there are 50 null records in this column in my data set. And for the weight column, I have 922 non-null values. So it's around 78 null values. I have my data set in which it has 1000 records, and out of which I have two columns in which one column is having 50 null values and another column is having 78 null values. By just doing df.info, I am able to get all of this information. And how do I find where are these null values? That is where df.isNull will help you. If I execute this, it is going to return me a data frame in which it is of same shape of my original data frame, but at every position, at every index, it is going to keep either true or false. And if it is a null value, at that point it is going to mark it as true, and if it is not a null value, it is going to mark it as false. Now if you see here, you can see all of them are false because it is not printing all of your 1000 records. There might be some records inside this that are having null values, and at that position we are going to see it as true. And to visualize this neatly, I have created a short data set in which I have two columns A and B, and A column contains values 1, null, and 3, and B column contains the values 4, 5, and null. If you notice, when I say df.isNull, it is going to mark it as true whenever there is a null value. So this position will be true and this position will be true, and remaining are false, false, and false, false. So that is what we got here. Hopefully you understand the essence of df.isNull. But by looking at this, I am not able to get the count of null values, right? I'm able to get where the null value present. That is where another function comes into picture, which is called df.isNull.sum. So if I execute this, it will show me my age column contains 50 null values. And you can achieve the same null treatment by using another function called df.isNa. It is going to be the same output as df.isNull, and you can use either of them to get the output. Now if you want to calculate the percentage of null values in each of your column, you can do something like this. So let me explain. So I have in total 1000 rows, so it is 100%, right? And in one of the column, let's say I have 50 records which are null values. So if I consider 1000 rows as 100%, if I have to calculate how much percentage, 50, and if I do something like this, x equal to 50 into 100 by my total number of records, right? That's what I'm doing here. I am saying get me the sum of number of null values inside my data set, which is this value, multiply it with 100, which is this one, divided with the number of records in my dataset, which is how you can get df dot shape of 0. And if I execute this, I get to see percentage of null values in my dataset. So I can say that my dataset contains 5% of null values inside my column age and 7.8% of null values inside my column weight. And I can achieve the same thing by using a for condition as well, and I can do the same here and I get the output. Here I'm printing one by one as well. Now that you will understand how to find out the null values and where to find out the null values, now let's see how you can deal with them. In majority of the cases, if the percentage of null values are very small, then it is beneficial to drop those records rather than keeping them, because not having information in your table is not going to be of any advantage, right? And you need to decide based upon a use case. But for now, let's understand how you can delete those records in which there are null values. So that is where drop NA comes into picture. So what it will do is, let's suppose there is a null value here. Let's assume like that. So when you say drop NA, it is going to remove the whole record inside your data set. That is why the number of records got reduced. It has deleted all the records in which there are null values at any point. And if you see df.shape, we are going to get the 1000 only because we haven't executed df.drop in place equal to true. Whenever you say in place equal to true, that means it is going to modify your original data frame. So I will show you that now. And if I say like this, and my df will be 876 rows and 8 columns because we dropped all of those records. And let me read my data frame again so that I have my full data frame in which they are having null values. So what threshold parameter will do is, so let's say if I execute this, it is going to keep my whole 1000 records. Let me explain that. So whenever we say threshold equal to 6, so what it's going to do is, for every row, okay, for every row, it is going to check for all the elements inside your columns. Here in this data set, I have 8 columns. Here I specified threshold as 6. So what it means is, it will check whether this row, which is containing 8 columns, out of which if it has at least 6 non-null values, keep it, or else drop that. Out of these 8 records, if 6 of them are not nulls, then it is going to keep the record, and 6 of them are nulls, it is going to delete the record. And when I say threshold equal to 6 and when I executed, I got 1000 rows. That means in my data set, there is no row or no record in which at least 6 of them are having null values. So if I say threshold equal to 8, so what I am saying is all of my columns at every record should have a value. That means at least 8 columns should have non-null values. And because I do have some null values in my age and weight column, it is going to reduce the number of records. Let me execute this again and let me show you the output. Now I can, let's do it 5, and if I execute this, it is going to give me the whole data set because there are so all the records in which at least 5 of them are non-null values. Now let's talk about subset parameter inside drop NA. So far we have seen df.drop NA, right? So what drop NA will do is, it is going to drop all the records in which there are null values at any point. But can we also drop based upon a column? How can we do it? So that is where drop NA subset will come into picture. So what I'm going to say is, get me all the records in which weight column is null and drop those records itself. Let's say these are the records in which weight column is null. Then it is going to delete only these records. It is not going to delete records from other columns in which they have null values. So that is what subset will help you do it. So I can just do like this and I get the output as 922 records. And I can do like this. Once I drop the records using subset column, now if I calculate the null values, it is not going to present any null values in that column. But we do have the null values in the other columns. Hopefully you understand the difference between subset and normal drop NA. And I can do with any other column as well. And if there are no null values, it is going to keep it same as it is because there are no null values. And I can get the shape again. And now you can mix and match with other columns as well. Let's say I'm saying df dot drop in a subset city and age. Now what it will do is, first it will check for all the records in which city is null and it is going to delete those, and then it comes to the column age in years and it will check whether there are any null values and it is going to delete those records. In our scenario, there are no null values inside city, so it is going to keep as it is, and there are null values inside your age, so it is going to delete those 50 records in which it has null values. So my dataset become 950 cross 8, and I can do calculate as many possible combinations as I get, guys, and I can do multiple columns combination as well. So likewise we can drop the records based upon the null values and based upon the column values as well. And there is one more important parameter called how, and what it is going to do is, let me execute df here. If you notice, I'm saying df dot drop in a subset equal to two columns in which city is having not null values and age is having null values, and here I'm saying how equal to all. Let me execute this. If I execute this, I am getting 1000 records. That means it hasn't dropped any of the records from my dataset. And why is this the case? When I say how equal to all, what this means is, first it is going to check for the city column, and if all the values are nulls, then only drop the records, and then come into the age, and if all the values are nulls, then only drop the records. Otherwise don't drop anything, because here there are no null values completely inside these columns. It is not going to drop anything. And there is one more parameter called any, and what it will do is, it will check for at any position in these columns, if there are null values, drop those records. Here if you see, I have the values. I got the less number of records because it dropped the values in which there are null values present inside these columns. If you have any queries so far, please let me know in the comment section below, and I'm going to reply to each and every one of you. How to find the indexes in which there are null values, that is also important, right? So that is where we can use np.where, and inside this we are going to give df.isNA. So what df.isNA will give you, it will give you a data frame in which it is having true or false, right? And here we are passing those inside np.where. So what np.where will do when you pass this data frame, it is going to give you the row number and the column number at which it has null values. So let me explain the output. So what it is saying is, at the index 21, correspondingly the column at index 3, it is having null value. So likewise it is going to return a pair of arrays in which the first one is row index and second one is column index, and if you combine both of them, you can pinpoint the values at which it has null. Okay, let's do that by using a lock function we have learned in the previous chapter, right? Now let me execute df.columns, and if I have to give index, it is 0 1 2 3 4 and 5 and 6 and 7, right? Here what I'm saying is lock of 997. I can execute this, and I'm also executing 21 and weight in kgs. Let's do all of those things. Okay, so this is the first example here, lock of 977. If you see inside 977 record, we have a parameter called weight in which it has null values. But if I access like this, I'm going to print all the records, right? Let's do like this. I'm saying get me the 21st index value, and for this column it is going to have a null value, and I can just do np.where df of age dot is null, and it will return like this. And I can set the values actually. Let's say if I do like this, and I will keep it as 30. Let's execute this, and we are going to do the same thing again, and if I do this, it is going to keep the value as 30 because we have assigned a value 30 to a value which is currently nan. Hopefully that is clear. So by using the combination of these arrays, we can pinpoint the exact location in which it has null values. Let's understand how to get the data set in which it has only null records. So what I'm saying is df of, and say df of the column that you want dot is NA, and if I execute this, it is going to give me the data frame in which the weight column has null records. So likewise you can filter the data frame to see which columns has at what indexes we have the null values. Now that you have learned about how to find null values and how to pinpoint the null values and how you can calculate the number of records that are present inside your dataset as null records, so what to do with those things, that is also important, right? Now to understand that, I have created a short dataset in which it has 4 columns, and let me execute this and show you. So this is my data frame, and in which I have multiple null values. So one thing I can do is I can drop all the records in which there are null records. So if I do like this is my original data set, which is of around 10 records and 4 columns. And when I do df.drop NA, it came down to 3 by 4, guys. That means we have a huge data loss, right? Not every time you have to use drop NA, guys. It is very dangerous actually, because you are reducing your data. But I can do drop NA how equal to any. Even this is going to do the same thing, because we are dropping the data set in records in which it has null value at any position. Okay, and I can drop based upon the column wise as well. If you see here, every column has at least one null value, and when I say df.drop NA axis is equal to 1, it has dropped all the column values. That means I don't have the data frame to start with here. I only have the index. What to do in this scenario? You have to understand what you are going to do with these null values. If you randomly do df.drop NA, it is going to reduce your data drastically, guys. And one possible thing that you can do is I can fill the values with 0 as well. If I do like this and if I execute, I can see that these are numerical columns A and B and C, and if I add 0 here, that means it is little bit okay. That means it is like number only, right? But if you look at the column D, it has a string values which is X, Y and Z, and if I add 0 in between, it is not going to sit through correctly, right? In that scenario, we are not going to fill NA with 0. It is a good option, but you need to decide when to do fill option and on which columns you have to do fill NA as 0. Instead of filling NA as 0, you can fill with mean value of that column as well. And if I do df.fill NA df.mean, it is going to fill the null values for the mean value of that column. It will calculate mean of A. It is going to fill the value in which there is a null value. But here, as you cannot calculate mean of a string, it is still going to have null values, right? So in that scenario, what you can do is you can fill up with mode. So if I do this, we have filled up our data set in which it has the most occurring column in D. But here, one more problem we noticed, which is inside ABC, we got X values. So in that scenario, what you can do? So that is where you can mix and match the above stuff. So here I have a updated code in which I am saying fill the values of columns A and C with the value as 0. Okay. And for the column B, fill the null values by using a mean of that column. And for the column D, fill it with using the mode of that column. So by doing the individual operations, you are able to handle null values at every column differently and uniquely. And if I execute this, I get the output something like this. So likewise, we can handle the null values inside your data frame. And that's it for this video, guys. We have learned how to find null values and how to pinpoint null values and how to override the null values, and how we can impute the other techniques like fill NA, fill 0, and then mode, mean, and a lot of other stuff as well. This is not the end of null value treatment, guys. Moving forward, we will learn a lot of more variety techniques on how you can handle null values more efficiently. And one thing remember, if your dataset contains around 90-95% of null values at any column, it is better to drop that, because it is not going to provide you more information, because most of the columns are null values. If you have any queries, please let me know in the comment section below. And if you are liking what you are watching, please do subscribe and click that bell icon to get notified daily, and we'll meet in the next video. Bye bye.